Hello, everyone, and thank you for joining us for today's webinar hosted by our Solutions Engineering team. Today, we will discuss how to keep your monthly AWS spend on budget with Terraform and AWS Lambda. I'd like to introduce you to our presenter today. Sean is a Solutions Engineer at HashiCorp. Sean is going to introduce Terraform and demonstrate how to deploy a serverless application to manage AWS instance lifecycles. Finally, Sean will give a demo and wrap up by answering questions about Terraform. I also want to note that this webinar is recorded and the recording will be made available after post-processing. With that, let's go ahead and get started. Take it away, Sean.
Thanks, Amanda. Welcome to the HashiCorp webinar series. This week we'll be talking about how to rein in your cloud costs with Terraform and AWS Lambda. This is a guide to reducing unnecessary AWS spending. So in today's webinar, we'll show you how to deploy a cleanup bot into your AWS account to save money and reduce waste. This tool is open source and it's freely available via the HashiCorp Guides Git repository. It's the same code our solutions engineering team uses internally to manage EC2 instance lifecycles. A little bit more about me. I'm a HashiCorp solutions engineer based here in Austin, Texas. I'm a former systems administrator, and my first computer was a Commodore 64. I enjoy building robots and automating things, and when I'm not in front of the keyboard, I like to get outside and go hiking and do outdoor activities. This might look familiar to many of you, the sticker shock or feeling when you get your first AWS bill and it's more than you expected. So what can we do to address this issue? Let's answer a few questions here and see if any of these questions relate to you. The first is, who created all these resources? When you log on to your Amazon console, you'll see a whole bunch of stuff running. Unfortunately, it's not always easy to tell who created things and track down who owns what. Instances can be created without name tags, making them a little bit like an orphan pet with no name tag, just sort of wandering the street, and you have no idea where the owner is. What sizes of instances are we running? Amazon prices their EC2 compute instances by size, which corresponds to the amount of CPU, disk, and memory that you'll get. One thing you may not be aware of is that each instance size is roughly double the compute capacity and cost of the size below it. So a micro instance costs twice as much as a nano, and a small costs 4 times as much as a nano, and so on. The next W question is when? When is it safe to shut down or delete resources? Particularly in developer and QA or demo environments, this can be a huge problem. If you don't know whether an instance is running something critical, you might be afraid to shut it down or terminate it. Where are all my instances running? Remember that each AWS region is like a completely separate data center. It can be easy for instances to hide out in some far-flung region of the world if you aren't watching things closely. And the final question is, why are we leaving the water on? Buying compute capacity nowadays is a lot like paying for electricity or water. As soon as you turn it on, the meter starts running, and if you leave it running, you have to pay for every single hour of usage. So the most important question is, how are we going to fix this mess? Let's take a closer look at some of the causes of cloud overspending. So this is based on a true story from one of my previous jobs. It's the story of our first cloud project. The developers were working on a very tight deadline to deliver the latest version of their application to production. And developers care about writing and testing their code and fixing bugs. They're not so concerned with the infrastructure that's required to run their code. Sysadmins, on the other hand, want to be very careful and not break things. In operations, stable and boring is good. So dev and ops have competing priorities. And sometimes there can be some friction between the developers and the sysadmins, and this is what was happening. The provisioning process was slow. Developers would come to my team and ask for a dev environment. Sometimes it would take days or even weeks to get that set up due to all the different, departments that had to work together to build the dev environment. Approvals had to be made, VMs had to be created, then you've got to go and assign network and firewall information. So that process was very frustrating and slow for the developers. This led to some missed deadlines and unhappiness. So the dev teams got permission to move some of their workloads into AWS, and they were really excited. It's not that hard to set up an AWS account. All you need is a valid credit card, and you can start paying for your compute, disk, and memory by the hour, or compute disk and memory by the hour. That's exactly what our dev team did. And for a while, things were great. The developers could provision their own virtual machines or instances in the cloud, and the operations folks, or my team, had a lot less to worry about. Things quickly got out of hand. I like to call this the dev romper room. Imagine if you sent 25 kids into a candy store, each with a basket, and said to each child, just take whatever you need. That's kind of what happened to our AWS account. It was a free-for-all, and it got to be messy. Now, people aren't bad. They mean well. But humans aren't perfect, and they sometimes forget to shut things off. The more instances you run, the more money Amazon makes. And so Amazon's not highly motivated to help you other than to provide you some data and an API to work with. Beyond that, though, they're not going to stop you from creating more resources than you need, because that's how they make money. So the end result of this story was we received this huge AWS bill. Needless to say, the CFO was not thrilled about it, and some discussions were had about cutting costs and being more efficient. Maybe you've experienced this too. Let's see how we can get a handle on our AWS spending and reduce waste. The first step is to know where your money's going. This is a graph from the AWS Cost Explorer. So we highly recommend you take some time to get familiar with AWS Cost Explorer and the types of graphs that it can create for you. This is the stacked graph, which breaks down the most expensive resources by type. So the setting that you want to make sure you have turned on here is group by usage type. And that's going to break everything out into these blocks where you can see here's the M4 large. And this one's in T2 micro, T2 small. These are all EC2 instance types. Inside of the green bar, others, if you dig inside and take a look, most of that is also EC2 spending. So the trend that we see across many, many users is that they spend the most amount of money and waste the most amount of money on EC2 compute. One study I read recently estimates that most users overspend on EC2 instances by 30 to 40%. That can be a staggering amount of money if you work in a larger shop. So now that we have a clearer idea of where our AWS spending is happening, let's look at some ways to reduce costs. So since most of the wasted spending is on EC2 instances, that's where we're going to focus first. But you can take the code that you'll get from this webinar. If you want to add features to manage things like NAT gateways or RDS instances, you could do that too. The three top things you can do to reduce EC2 spending right away are here. The first one should be pretty obvious. Shut off anything that's not in use. It's just like leaving the lights running all night when no one's in the room. And do you know why people don't remember to shut things off? It's not because they're bad people. It's because they aren't paying the bill. And when you see that an instance only costs 25 cents an hour, well, that doesn't sound so bad. But when you add it up across an entire month, it's $180 a month. Now that seems much more significant. Spin up several of those instances, and your bill can, quickly escalate and grow. The second thing you can do is choose the optimum instance size for your workloads. If you're running on an M4 large, but a T2 medium would suffice, well, you could cut the cost of running that instance in half. So take a look at your health checks, your CloudWatch logs, and make sure you're not buying more EC2 instance than you need. As for this third item, we recommend you get some historical data and get number 1 and 2 under control first. The reason for that is you want to know exactly what your usage patterns are before you go buying prepaid instances a year or 3 years in advance. So the idea is we don't want to buy a bunch of instances until we really know for sure exactly what we plan to be using. These are the top 3. This webinar is going to focus on number 1 here. That's the lowest hanging fruit, and it's going to be generally the easiest and quickest way for you to save some money. So now that we've identified the problem, gotten some visibility into our spending habits and what we need to fix, let's develop a plan. Our goal is to create a simple serverless application to clean up unused and expired AWS instances on a regular schedule. So with that in mind, we developed some project requirements, and here they are. First, it has to be an automated process. Don't depend on humans to always do the right thing because you'll be disappointed. Number 2, make it easy for your users. Everyone who creates resources inside your AWS account needs to agree to your standards. Number 3 is going to be make it easy to exclude instances from your Reaper bot. You may have long-running infrastructure that you need to keep around, and you don't want to accidentally delete these things. So we need to make a way to whitelist instances. The next requirement is a TTL, or a time to live. TTL is the expression of the maximum time you think you'll need a resource. So this trains your users to think carefully about how much they'll need. And your cleanup bot will also use this value to know what can be safely deleted. Now we also have to be able to deal with unidentified or orphaned instances. Just because we have a great system for tagging and identifying everything doesn't mean some things won't slip through the cracks. Once in a while, you'll have unidentified resources that no one wants to claim. You'll need a process and a system to deal with those. We also want to be able to contact anyone who's created resources in our account. So part of our application is a way to identify who created an instance and how to contact them. And finally, we want to provide visibility to our entire team via chat or email messages so that folks can know what's going on inside of our AWS account. So that's the goal and our project requirements. Let's look at some of the pieces we're going to use to put together this application. Tags. Tags are a way to add your own identifying information to AWS resources. You can show your tags in the AWS console as we've done here. And how you tag things is really up to you. It's sort of like an empty dry erase board. You can tag your instances with anything you want, including emoji. If you haven't done so already, you should sit down with your team and create a tagging standard for your AWS instances. So in our example, for this application, we have 2 mandatory tags, namely owner and TTL. The owner maps to the email address of the person who created the instance, and the TTL is the maximum number of hours that we want to keep this instance around. So it's the maximum lifetime of the instance. Those are the only 2 mandatory tags that we've designated for our cleanup application. AWS Lambda is also known as serverless compute. It allows you to run your code without having to build a Linux or Windows server to run it on. So you can write AWS Lambda functions in Node.js, Python, Java, C# or Go. Our cleanup bot is written in Python. So in the old days, we would have created a Linux server and some cron jobs to run our application, but now we don't have to. We don't need to go and install Ubuntu or Red Hat to run this thing. Amazon's provided a complete environment for running our functions, and we don't have to worry about the underlying infrastructure that's going to make it work. So if all I care about is having an environment to run my Python scripts, AWS Lambda is a great fit. Terraform is an open source tool for provisioning any kind of cloud or on-premise infrastructure. Traditionally, you might think of Terraform as being used to stand up your Linux and Windows VMs or cloud instances, but it can do a lot more. There are hundreds of things you can create in AWS with Terraform, not just compute instances. Terraform can be used both in your data center and in the cloud. It's very easy to learn and easy to use. And there's also an enterprise version that offers advanced features such as role-based access controls and state management for your production workloads. Those are all the building blocks for our application. Now we're going to go ahead and build a cleanup robot. This is one of my favorite robots. His name is Mr. Trash Wheel, and he lives in the Baltimore Harbor. Mr. Trash Wheel also has his own Twitter account, so if you'd like to go and keep up with Mr. Trash Wheel's adventures, you can. Some of you might even be old enough to remember Rosie the Robot from the Jetsons cartoon. Cleanup robots are no longer the stuff of science fiction, so now we actually have real robot vacuums that can respond to voice commands. I just read in the news recently that Amazon has gotten a patent for robots that clean up after other robots. Let that one sink in for a moment. So instead of picking up trash, our robot is going to clean up expired AWS instances and notify our users via Slack or email. So there are two components. There's the actual cleaning up and managing of EC2 instances, and then the communication part where it's letting the human beings know what's going on. And give your bot some personality. Have a little fun deploying your cleanup bot. Here's one that we use internally. The bot's name is Nepter, and Nepter is sending us an AWS instance usage report. This is a high-level report that shows us how many of each instance size we're using across the entire account. It's not meant to be comprehensive. It's just meant to give us kind of a benchmark and just to see what's actually running every day. So, for example, if you don't normally run an extra large, R4 extra large, you might look at that and go, let's go ask and find out who's running that and what's on that instance. This is another report for termination of expired instances. So this is our Reaper bot. It's known as the Reaper because it comes for the souls of your AWS instances when their lifetime is up. These instances all expired. Their TTL was up. And so the Reaper bot sweeps through every hour and deletes anything that has passed its expiration time. You might be curious about how much money you could possibly save by implementing a system like this. So this is some sample data from one of our internal accounts, and I've labeled the graph at a few places. Start nagging is where we start to ask our engineers, politely of course, to shut down anything they don't have in use. So all those instances that you ran for a demonstration or training or a POC, could you please shut them down when you're done? And we saw a little bit of a result. The daily costs started to kind of trend down. The next marker is the wall of shame. So the wall of shame is one of the reports that our cleanup bot can send. It's a simple leaderboard or a scoreboard showing who has the most untagged instances. So we kind of have made it into a game. And the idea is if you're on the wall of shame, tag your instances and get yourself off the wall of shame. So that was also effective. That helped reduce costs some more. And then we actually went live with the Reaper bot. This is where we started putting instances to sleep and deleting them if they had passed their TTL. And so you can see quite a drastic drop between, the daily spend here. Now it's hovering down around here. So from a peak up here, we've dropped over 50% down to our current daily average. Huge amounts of savings you can recoup in developer and QA accounts where you didn't have any kind of management of this stuff. So we can't guarantee these exact results, but they are pretty common. It's not uncommon to see a 30 to 40% reduction in your daily costs. So that's not that out of the ordinary. Before we go ahead and deploy our app, though, I have to give you a warning. This app we're about to launch can and will delete your AWS instances. So do not deploy it to production unless you are absolutely 100% sure you know what you're doing, that you've reviewed the code, and ideally you have some sort of approval process wrapped around your deployment of this application, we like Terraform Enterprise. If you'd like to talk to us about Terraform Enterprise, just reach out to the email that you'll get after this webinar. With that out of the way, let's go ahead and jump into a live demo. Just a moment while I escape from PowerPoint. And we'll start with the source code. Everything begins at the source. So this is the GitHub organization for HashiCorp, and inside there are these repositories. This one's called Terraform Guides. Terraform Guides is full of examples and code snippets, Terraform configs that you can use to learn Terraform and to stand up different types of infrastructure. So you can see here we have examples for creating EC2 instances, Google Compute, and Azure. Today we're going to be working with this one. It's called AWS Lambda EC2 Lifecycles. So this guide has got all of the instructions and source code that you'll need to deploy the same application that we're going to demonstrate in a moment. So this guide is free, it's open source, and you can download this if you like. So I've done that. I've actually downloaded this code to my machine, and I've got it all stored here. Before I run it, there's one setting I need to configure, and that's my Slack webhook URL. Now, if you don't have Slack, don't fret. You can use this with email as well. So we've set it up so you can use either Slack or email. If you do have Slack, you'll want to create a webhook. This is what's going to allow your bot to chat with you and report in with your AWS reports. You can give it a name. You can give it an icon or a custom emoji if you like. And this is the face of your bot. This is what your bot will look like inside of the chat channel. So I've got my webhook URL. I want to go ahead and put that into my variables file. So this is the same code. Actually, that's the wrong code. Let's go ahead and open the correct one. That's better. Okay. So down here in variables, these are all the configurables for our bot application, one of which is the Slack hook URL. So that's really the only thing you need to configure. The rest of these are optional. You'd want to put this to the Slack channel that you're using, of course. And the rest of these I'm going to leave as their defaults. Now that I've set up my variables, I can run Terraform. Now, if you haven't used Terraform before, we've got some great tutorials. It's really easy. You can pick it up inside of an hour or two, or over your lunch break if you want. Download it and run it. It's about that simple. Maybe you have a few config files. And Terraform runs on Linux, Mac, and Windows. So right now I'm running it out of PowerShell. First thing I'm going to do is Terraform plan. So like I said earlier, everything starts with a plan. Terraform is no different. And when I run Terraform plan, it's doing a dry run. So what it's doing is looking at all my Terraform configs, and then it is going to map out what needs to be built and in what order everything needs to be built. And if you want to take a look at the graph, you can actually run Terraform graph. This will actually generate a visual graph. You can read it in a GraphViz or a similar program and see exactly how all the dependencies are mapped out. So that's kind of a slightly advanced topic. Just know that it's automation and it works. It's like magic. So I'm going to run Terraform apply, and we'll auto approve since it's just me. Now in production, you'd probably want to have someone else approve this change. And that way you get a second pair of eyes on it, and you're making sure that you're, testing what you push out to production. So now it's taking everything that it had planned to do and actually building those things inside of the AWS console. And if I hop in here, You can see where previously there were no functions. If I reload, okay, it's built 5 of them. I'm waiting for 7. So now all 7 are there. Terraform run is complete. So that was it. Super simple, huh? Takes less than a minute to deploy this app, and it's ready to go. So we could start testing it right away. This is the Lambda dashboard. This is the AWS console. While you can manage things and configure things in here, we recommend using Terraform instead. There's some reasons for that, which I'll cover in a moment. But it does make for a good demo. So let's browse around and we can take a peek at some of this code. 3 of these functions are system functions. So all the ones that begin with the word get, all they do is get information that other functions will be able to use. That's why they don't have a trigger. So AWS Lambdas have this idea of a trigger. The trigger is what's going to cause my Lambda function to run. And in this case, we don't have a trigger because the thing that makes it run is another Lambda function. Over here, you can see the things that my Lambda has permission to access or read from. So these are different parts of Amazon that we've given permission to our script to read. Down here, they've provided you with a handy little source code editor. Good for debugging. Don't recommend doing all of your config and deployment in here. It's better to store your code in a source code repository and then deploy it either from the command line or via your deployment tool. Down here are environment variables. So this one only has 1, and these are the required tags that we're going to look for. And like I mentioned earlier, we have 2. Those are TTL and owner. So that's a quick tour of the Lambda function. You've got a handy test button here too. So if you want to test a function, simply click on test. The page is misbehaving, so I'm going to reload. Let's try it again. There it goes. Okay, so what's happening now is the function has been triggered manually by me using the test button. It's combing through all of my instances and checking their tags and saying, do you have your correct tags? Do you have your correct tags? It's going to compile a list and then return all of the tagged instances back. This function is used by the Reaper function, this one here. So this one's going to actually check the TTL tag and terminate any instance that is expired. So we have functional or system functions, and we have notification functions. So the ones that start with notify, these are simply informative. This one that we tested earlier that shows instance usage, that's right here. So this is going to show what sizes, how many of each instance we're using. That's the one I showed in the slide deck demo. The notify untagged instances is that wall of shame I mentioned. So if you want to unleash this on your coworkers and have fun with the wall of shame, you could use that one. And then these 2 actually have the ability to stop and terminate things. These are the ones you need to be careful with. So I'm going to show you how to set these up now so you don't shoot yourself in the foot. Clean untagged instances. This is the grease trap of our application. Everything that falls through, doesn't get tagged properly, or is untagged completely. This function is meant to catch all that stuff. So we have sleep days. That is the number of days after which we shut off untagged instances. And the assumption here is that, hey, it's been running for 2 weeks. No one has claimed it. It's been untagged for that long, so we're going to shut it off. We're not going to delete it. We're just going to shut it off. And then if anybody screams and hollers, then we can, scold them for not tagging their instance, and they can turn it back on. After 90 days, we've assumed that, it hasn't been running for 90 days. No one really cares about it that much. We're going to delete this thing. These numbers are, of course, configurable. You can set them to anything you want. Now, this is your safety switch. Is active. The default is false. So if I run this now, if I run this function now, it's going to do a dry run, and it's going to actually tell me that it is still in inactive mode. So I'll run it once in inactive mode, and then we're going to switch it to active mode and run it again. So we should see the results pop up here in just a moment. You can see here it is in active mode. So I had it active earlier, and I've shut it off and turned it back to false into inactive mode. I feel like we need some Jeopardy music here. Na 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 na. No. Hey, it's config management. I got to work with the material I got. There it goes. Thank you, little bot. Okay, so I would have stopped this instance. This is test mode, and you should use these functions in test mode until you're really sure you know how they work. You should see a message in Slack too. Yeah, so there it is. Some instance out in EUS2 is going to be put to sleep. Okay, that's fine. Now let's go ahead and make this active. Now I could just do it right here, but we want to go ahead and add some process and use Terraform to do this instead. So I'll go down into my config file. We're going to change as active to true. And I also have a couple of spots where you need to uncomment some code to make it active. Sleep instance and terminate instance. The reason we ship this commented out is for safety's sake. I would hate for someone to accidentally delete production because they weren't sure what they were doing. So it does make it a little bit of an extra step to deploy this, and that's for a good reason. So this one's ready. Now we'll do this one as well. We're going to uncomment the lines that make it really work. Okay. Now there is one extra step, and you could automate this if you wanted to without too much trouble. We have to recreate these zip files. I'm just going to do it by hand for now. Lambdas are stored as zip files. The reason for that is you might have multiple files inside your Lambda in case you were using some support files or libraries. You pack it all up into a zip file. So that's how that works. So what we'll do is go down into the Git repos. So just take a second. And the two files we changed were clean untagged instances. That's our janitor function. And check instance TTLs, this is our Reaper function. So we've now recreated those zip files. And Terraform can actually detect the changes. So if we do Terraform plan again, Terraform is going to notice that, oh, we changed is active to true, and the source code changed. This would be one of those places where it might be nice to have an approval process or someone to say, yeah, I think we should make that active. I mentioned earlier, Terraform Enterprise can handle that, or you could build your own system. But when you're pushing this type of code to production, it's good to have some checks and balances, some safety wrapped around it. Let's do a Terraform apply. Neat. So you'll notice also that Terraform didn't have to recreate the other 23 parts of the application, just the two things that changed and the environment variables. If I go back into the UI now and reload this page, You can see that the stop line is uncommented. Terminate line is uncommented, so those changes made it through. And we're now active. It's actually true. Let's test this one more time. Now, while that's running, I'm going to go ahead and do the other instance, or the other function, rather. And I've got some sample instances that we can try and terminate with the bot. And we've put different data into the TTL just to see what happens. So I have a -1, which means preserve, don't delete. 0 means it's expired as soon as you created it. That one theoretically should get deleted. 9,999 hours from now, the Bitcoin farm will go away. You can put emoji in here, by the way. We put this emoji for testing purposes to see if it would break or what would happen. Let's go ahead and run the Reaper. And my theory is that at least one of these, actually only one of these, should get deleted or terminated. Okay, it finished, and sure enough, the expired instance is getting terminated. Now let's fix these TTLs and make them something smaller. Okay, now they have valid TTLs and will be considered tagged. So we decided to err on the side of caution. If you don't have both owner and a valid TTL, the instance is considered untagged. We don't want to accidentally delete something. So err on the side of caution with that. Let's run the bot one more time. This was the most recent run. We should see one more pop in here in just a moment. Okay, there it goes. So there are the two instances. You can see the expiration time. And there's the bot doing its thing. So this is meant to run on autopilot. You set it up, configure it, and forget about it. And as long as people do the right thing and tag their instances correctly, they will get shut down and terminated on a schedule. So that's a tour of the AWS cleanup bot and application. Let me show you how easy it is to tear down. Easy peasy. So all 25 of those resources were destroyed. So you might be curious, why Terraform? Why should I use Terraform to deploy this Lambda application? There are a few good reasons you want to consider using a tool like Terraform. The first is that it's easy. It's so easy to use. In fact, once all this is set up, it's much easier than going into the GUI and trying to build a function out with the pointing and clicking and connecting things together. All of the dependencies are taken care of for you. All the cleanup is taken care of for you when you want to tear down an environment. So this makes Terraform a great tool for dev environments, for testing. Another advantage of using Terraform for a tool like this is that now the whole team can understand it and deploy it and maybe even make adjustments to it, even if they don't understand the underlying code. So Terraform is a sort of a lingua franca. It's a universal language for config management. And even if my team member is not a Python expert, well, they understand Terraform, and so therefore they could also manage this application and troubleshoot it. So it's much more efficient that way. So it's infrastructure as code is what I'm trying to say. Store your infrastructure as code, and you'll gain the benefits of speed, increased efficiency, and you can also decrease risk. So store all this code in a source code repository and then have an approval process around it. And that way it's safer to deploy because you have multiple people checking on each and every change that you send to production. So that kind of brings us to the end of the live demo. I'm going to hop back to the slide deck for just a moment. And we'll swap these. This was the first part of a two-part webinar. In the second half of this, we're going to show you how to save even more money. And the topics will include actively enforcing tagging standards using Terraform Enterprise and Sentinel. You can learn how to require approvals for larger, more expensive instance types. Centralize your Terraform state management to reduce waste and orphaned resources, and also how to track all infrastructure changes with audit logs. So that's coming up. Be sure to mark your calendars. I think the date's on our events page. Some useful links. We'll also post these after the webinar. If you want to download the code, that's the link there. And then we have a AWS and Lambda Slack tutorial, and of course a link to Terraform Enterprise. So that brings us to the end of the demo and presentation. I think we can open it up for now for questions. So over to you, Amanda.
Thanks, John. Okay, so we have a few questions from the audience that are coming in. The first question, Sean, someone's asking, how do you enforce resource tagging, and is Terraform a good tool for IAM policy management?
That's an excellent question. There are a few ways you can enforce resource tagging. The first is politely ask everyone to tag their resources. You'll have mixed results there. To be quite honest, humans make mistakes, we forget. You can't necessarily rely on people to tag everything. A practical approach to enforcing tagging would be to use our tool Sentinel. So Sentinel can actually test your Terraform code and make sure that you've actually included the required tags on each resource that needs them. And that's part of Terraform Enterprise. If you'd like to take a trial or take Terraform Enterprise for a spin, just reach out to us after the webinar and we'll be happy to give you a demo.
Nice. Okay. And the next question is, are you storing your state files on S3?
No, we're not. In this example, I've just got the state file here on my local workstation. But that does bring up a good point. The state file is important, and you want to make sure that you don't lose it or delete it accidentally. We do have some tools that can help you with centralized state management. Those come with Terraform Enterprise, of course. Or you could build your own tooling. Many users, have another system for managing state files. The choice is up to you, but in this example, no, we're not storing the state file in S3. You can, though. That is supported.
Okay, and then someone's wondering if the code's only available for EC2 instances, and would it work with RDS instances too?
Today it's just EC2 instances, but we've designed it in a way that it should be fairly easy to expand. So on the roadmap, I'd like to add support for NAT gateways and RDS instances. One way to tackle the problem is to find out what's costing you the most money. So if in your environment, RDS is the biggest spend, by all means, copy our source code, change it. Even better, if you want to contribute back and add an RDS cleanup bot, we'd love to see contributions or pull requests.
Awesome. Okay, and someone's asking for a little clarification on the role of Terraform here. Sean, they asked, can you explain how Terraform helped in this cleanup process?
Yeah, absolutely. The prototype for this cleanup bot was built by hand. Just got into Lambda and started connecting things together. The problem with building things that way is that you don't have a record of how it got built. Let's say, Sean built you this great, bot for cleaning up your AWS resources, and all the source code was in his laptop. or personal Git repository. Um, Now, that doesn't help the other members of my team who might need to troubleshoot this thing or they might need to redeploy it. I could leave and go to a different company and nobody would understand how that thing works. So instead of just kind of building things by hand and maybe documenting them or not, we want to shift to infrastructure as code. And Terraform enables infrastructure as code. Um, all of the steps that are required to set up this application, this Lambda application, are encapsulated within the Terraform code in that repository you see there on the slide. So anyone, anywhere in the world can download this code, make a few changes, adjust the variables, and they can stand up this exact same application without having to be a Lambda expert or a Terraform expert. So repeatability is one reason to use Terraform. Another is for testing and even simple documentation. Just being able to confidently say, yes, I can reinstall that in a heartbeat. It's not a problem. If it goes bad, I'll just tear it down and build a new one. Whereas if things were configured by hand, it's a lot harder and slower to rebuild if you need to. So those are a few of the reasons you might want to use Terraform to build your cleanup bot.
Great. Okay. And next question is, so someone's wondering, how can you start managing AWS infrastructure that's already in operations using Terraform? So for instance,
yep.
can Terraform pull the dependencies of EC2 instances already in AWS?
Yes. The answer is yes. It's a two-step process, so we can't magically just point at a bunch of AWS resources and turn it into Terraform, but we can come pretty close. What we can do is create a Terraform sort of a skeleton config with placeholders for each thing that we want to import, and then we run the Terraform import command. We can actually import the settings of the running resource into our config so that the next time we spin it up, it'll be fully automated and stored as infrastructure as code.
Great. Okay. And someone's asking if step functions would be a better option for composing those Lambda functions together.
Probably. And the reason I didn't go with step functions is I'm brand new to Lambda. This is the first Lambda application that I've ever written. And if you wanted to take a crack at re-implementing this with step functions, we totally welcome your pull request.
Great. Okay. And then, okay, the next question, Sean, is how did you set up the colors in the Terraform output? Creating lines are gray, resource properties seem white. Is that a PowerShell feature?
Oh, I love this question. And this one's for all you Windows users. Unfortunately, Microsoft Windows is a little bit behind in terms of console emulation technology. The Mac and Linux people have got their fancy terminals, but I highly recommend Commander. So CMDER. I'll pull the website up here real quick. Commander is a console emulator. It wraps around PowerShell, sorry. You can run PowerShell or Bash or whatever you want inside of it, and it comes pre-configured with color support and a bunch of other really neat features. So one of my favorite things when I'm working on a Windows machine is Commander, and it's free and open source. You can download it here. And that's how you get color Terraform output on Windows.
Very cool. Okay, so someone is saying, are pull requests welcomed for Node.js version of those functions?
Absolutely. I would love to see a Node.js version of the cleanup bot. Feel free to reach out directly if you want to. You can hit me up on GitHub.
Great. And then next one's just a bit of a clarification, Sean. Someone's asking if Sentinel is part of enterprise only.
It is. It's enterprise only. And free trial is available. If you'd like to take enterprise for a spin, just reach out.
Okay. And okay, someone's asking, can Lambda tagging EC2 also work with tagging S3 bucket with deployed images to clean up?
You bet. You can tag almost anything inside of AWS. So expanding this application to support other types of resources like S3 buckets or images stored in S3 buckets, sky's the limit.
Awesome. Okay, and can Terraform deploy the Lambda function itself?
Yes, it can. And I maybe didn't make that completely clear, but when I ran Terraform apply, that's exactly what it was doing. It was deploying the Lambda function itself and all the supporting things that are needed to run the Lambda function. And that includes permissions, the role, the policy, the triggers, all of the different pieces that come together to make this app, including the Lambda function itself, all deployed by Terraform.
Great. Okay, and someone is asking if you're using any sort of tool for testing Terraform on mocked environment.
No, but I can recommend some great testing tools. If you'd like to test code itself, of course, there's Sentinel. You can use Sentinel for that. And if you want to do integration testing, there is a plugin for the Test Kitchen tool called Kitchen Terraform. And that allows you to spin up Terraform things and run tests on them.
Great. Okay. And now someone's asking, what's the best practice on maintaining TF state files?
Don't delete them or lose them. So I kid. But seriously, though, if you lose your state file, you'll have to go through and clean up all of the resources that you created. So you do want to make backups. If you're in a dev environment like I am here on my laptop, it might be a good idea to make a backup of your state file and put it somewhere safe. Take it a step further. You could store your state files in EC2 or another online storage service. S3 is Amazon S3 is supported out of the box. For enterprise and production level things that where you really care about it, you can't afford to lose that state file. Recommend either Terraform Enterprise or building your own CI/CD pipeline to manage the state files.
Okay. And then we're just going to take, I think, about 2 more questions, Sean. So
Okay.
This question is there a verbose option for Terraform apply command?
There is. It's an environment variable, and it's slipping my mind right now exactly what it is, but you can turn on verbose output. Just take a look in the Terraform docs, and you'll see the switch you have to flip to make that happen.
Okay. And then final question, can you briefly outline the benefits of Terraform over CloudFormation?
I can, yeah. I've used both. Both are great tools, but CloudFormation has some limitations that I feel like Terraform overcomes. CloudFormation is Amazon's internal provisioning tool. Okay, so you can find it here in the control panel. We're just going to go into CloudFormation. And like the name implies, you're building cloud things. You're building networks and security groups, VPCs, pretty much anything you can create in Amazon. You can do it with CloudFormation. The native language for CloudFormation is either JSON or YAML. And that can be a bit difficult to manage, especially for large and complex environments. Trying to wrangle 10,000 lines of JSON is not that fun, and I've had to do it. So the main complaint I've heard from people about CloudFormation is that it's too rigid. It's very hard to troubleshoot things and include logic in your code. Whereas Terraform is a human-friendly and machine-friendly language. It uses HCL or HashiCorp config language. So it's very easy to create Terraform configs, whereas CloudFormation is a bit more difficult, especially when you have complex deployments. The second reason you might want to consider Terraform over CloudFormation is multi-cloud support. Terraform supports all the major cloud providers and local virtualization. So you have this universal language you can use, whether you're deploying onto Amazon or Azure or Google Compute. Terraform works on all 3. So it's very flexible and extendable that way.
Great. Okay, thank you, Sean. So I think we'll wrap up questions there. Thank you to everyone in the audience for all your great questions today. I hope everyone enjoyed today's webinar and you were able to learn a bit more about Terraform with AWS Lambda. Thank you for joining, and a special thank you to Sean for his time today. And finally, as I mentioned at the beginning, this webinar was recorded and we'll make it available on our website after processing. And I will also post it on Twitter for everyone. Thank you and have a great day. Goodbye, everyone.